Hi everyone, my name is Leela Manikrishna. Now I am going to present a seminar from DLD Digital Logic Design on the topic of subtraction using r-1's complement method. So basically we use complement method to find subtraction. So the basic property is make sure that the two numbers having equal number of digits. So the numbers which are under subtraction must have equal number of digits. For suppose if we take subtraction, the first number is called minute and the second number is called subtrahend. So the number of digits must be equal in both minute and subtrahend, and the result is called difference. So this is minute, subtrahend, and the result is called difference. So the subtraction of two n-digit numbers m minus n. Here I am treating m as minute and subtrahend as n. In base r is radix. In decimal number system, radix is 10. This can be done as follows using r-1's complement method. So basically it is a three-step procedure. The first step is add minute capital M to the r-1's complement of subtrahend. Subtrahend is capital N. So the first step is adding minute to the r-1's complement of subtrahend. So the part which is to be subtracted is called subtrahend. So we have to find r-1's complement of subtrahend. Now I'll tell how to find r-1's complement. Suppose example, if we take 77 base 10 to find r-1, that is 9's complement for 77, we have the formula. So from the given r is 10 radix, n is number of digits present in the given number is 2, and capital N is the number itself. So the formula for r-1's complement is r power small n minus capital N minus 1. So by using this formula, we can find the r-1's complement of the subtrahend. Now I'll use this formula. So then we'll get r-1's complement. So that should be added to the minute capital M. Mathematically, it can be represented as follows. Capital M minute minus subtrahend capital N is equal to m plus, instead of this subtrahend we are taking this r-1's complement of it, so then it will become r power small n minus capital N minus 1. So this is the first step in solving. So the second step is if capital M is greater than small n, that is if minute is greater than subtrahend, the sum will produce an end carry. So when we add both these terms, the sum will produce an end carry. Now it is to be discarded. Discard the end carry and add digit 1 to the sum. So here we are adding digit 1 because we are calculating using r-1's complement. If we calculate using r's complement, then no need to add digit 1. As we are using r-1's complement, we should add 1 to the end at the end. Next, third step. This is another case. If capital M minute is less than capital N, then the sum does not produce an end carry. This sum will not produce an end carry. and the sum we get is equal to the r minus 1's complement of capital N minus small capital M is equal to the r minus 1's complement of capital N minus capital M. So to obtain the correct answer, again we should take r minus 1's complement to the sum. To obtain the correct answer, take r minus 1's complement of this sum and place a negative sign before it. And place a negative sign before it. So this is the third step. If capital M is less than capital N, the sum will not produce an end carry. So it is equal to the r minus 1's complement of capital N minus capital M. So to obtain the correct answer and final result, we should again take r minus 1's complement of the sum and we should place a negative sign before it. This is the third step. So the first step is to add minute to the r minus 1's complement of the subtrahend. So to find r minus 1's complement, we have the formula r power n minus capital N minus 1. So mathematically it is denoted as this one. Capital M minus n is equal to m plus r power n minus n minus 1. So the first case is if capital M greater than capital N, that is if minute is greater than subtrahend, the sum will produce an n carry. We should discard the n carry and add digit 1 to the sum. We are adding as we are doing from the r minus 1's complement. Next, if capital M is less than n, then it will not produce an n carry. Again we should take the r minus 1's complement of the sum and place a negative sign before it. Now I am going to explain a problem based on this concept. So the given question is, subtract the following decimal numbers using 9's complement method. So the first one is 3570 minus 2100, second one is 753 minus 864. As the basic point is, the number of digits in each number is equal, 4 and 4, 3 and 3. Now the first step. So in this subtrahend is 2100 and minute is 3570. First step, finding 9's complement to 2100. So small r, as it is a decimal number, radix is 10 and small n is the number of digits, that is 4, and capital N is the number itself. 9's complement is equal to r power n minus capital N minus 1 equal to 10 power 4 minus 2100 minus 1, 2101. So we got the answer 7899. Now we should add this 9's complement to the minute. 3570 plus 7899 and adding both of them. So here we can observe that n carry is produced. So we have to discard the n carry and add digit 1 to the resultant sum. That implies 1469 plus 1, 1470. This is the final result. Therefore 3570 minus 2100 equal to 1470. So this is case 1 where n carry is produced. In the second problem, 753 minus 864. Here minute is 753 and subtrahend is 864. The first step is finding 9's complement to 864. So here r radix is 10 as it is a decimal, n equal to 3, number of digits present in 864 are 3, and capital N is the number itself 864. So 9's complement equal to r power n minus capital N minus 1. So which is equal to 10 power 3 minus 864 minus 1, 865. 135. So we got 9's complement as 135. Now we should add this 9's complement to the minute. So what is the minute? 753 plus this 9's complement 135, 888. Here in this case there is n carry is not produced, so we should find the 9's complement to this one. So 9's complement of 888. So radix is 10, number of digits is 3, capital N is the number itself. 9's complement equal to r power n minus capital N minus 1, 10 power 3 minus 888 minus 1, 889, 111. So the result is 111, and we should place a negative sign before it, so it will become minus 111. Therefore 753 minus 864 equal to minus 111. So in this way we got the result. We can observe that first finding the 9's complement to subtrahend, we got the 9's complement. Now adding it to the minute, and as n carry is produced, discarding the n carry and adding digit 1, we get the final result. In the second problem, first finding the 9's complement of the subtrahend, next adding it to the minute. Here n carry is not produced, as n carry is not produced, again finding the 9's complement to the sum, and we get the 9's complement, and we should place a negative sign. So this is for decimal number system, that is radix 10. Similarly we can find subtraction using r-1's complement for binary number systems also. Thank you. Hope this helps you.